Word, because otherwise I forget. And let's take a moment and briefly just do roll. When I created this roll sheet, somehow I thought, let's make it every 8 days. So I have it for February 11th. I don't know why I did that. All right. Jolie.
Yeah, I'm here.
Hey, Jolie. Liz.
I'm here.
Hi, Liz. Annette. Annette's not here.
She's here. I just think her audio. She's
There
here.
you
I
are.
just don't think her audio is working.
Your audio is not working. No. Okay. Thank you for, there's so many boxes. I can't tell if there's motion or if no one's saying, so thank you for saying that. Hasher.
Here.
Hi, Hasher. Haley. Okay. Haley's not here, right? Okay. Mallory.
I'm here.
Hi, Mallory. Lainey.
Here.
You're here. There you are. Hi, Lainey. Camilla.
Here.
Hi, Camilla. Hannah M. Or Hannah R. Sorry, M is your. Hi. Sorry about that, Hannah. Diana.
Here.
Hi, Diana. Grace.
Here.
Hi, Grace. Hannah W.
Here.
Hi, Hannah. Which now I can say Hannah from Jennison. I talk about the car crash. Okay. Stephanie.
Hello.
Hello. All right. Awesome. I'm going to put my puppy out because he's just barking at me already. Great way to start the evening. All right. How's the quiz?
I'm still trying to email it.
Okay, that's totally fine. It wasn't meant to be hard, but I realized the frequency table can take a little while to just tabulate everything. So I kind of thought maybe 30 minutes would be a little tight. Feel free to email. If you need extra time, just let me know. I'm happy to approve extra time within the realm of reason, like a whole week. Probably don't need that much time. But otherwise, yeah. How are the questions difficulty level wise?
Pretty fair, I guess.
Okay.
Sorry, I just do have one question. I have half of it drawn out and half on my computer. So did you just want a photo of what was on the computer too, so it wasn't split?
It's up to you how you want to do it. You can upload what you have on the computer onto Course Connect if that's simplest, and then just send me an email, or you can send me an email with both of them, like the downloaded copy of what's on your computer and then the picture.
Awesome. Okay.
So that's good feedback, guys, because I think I probably had 5 requests for extra time. So maybe we need to make the quizzes a little bit longer so that we don't add that as an extra variable.
10 minutes longer would be good. Maybe
okay.
Yeah.
Okay. Yeah, we can definitely do that. So thank you for the feedback. And then if we take a peek, yep, Hasher, I appreciate that because I think that's true. I think we all kind of, when we're oh, no, it's not, well, maybe personal to you, but I don't think you're alone in that. So let me just take a peek real quick when our next quiz will be. We have quiz 3. Okay, well, quiz 3 is not till week 10, so we've got a little bit of time. Let's just have a quick reality check with the syllabus. Let me share my screen here so that we are all looking at the same thing. Okay, can you guys all see my screen? Syllabus, okay. So we're here. We are going to be talking about measures of central tendencies, and I will be introducing Lab 1. Lab 1 is going to be due at the start of class next week. To be honest, my goal is never to give you guys a ton of extra work. Everyone's super busy. It's COVID. It's like, I don't know, -1 degrees out there. We're coping with a lot. So once we go through the lab in class today, you literally only have to change one variable. It is very straightforward. My goal is the lab should take you no more than 20 minutes at that. So it should be no huge strain time-wise to complete that lab before the start of next class. So then next week, we're going to talk about measures of variability. We'll go over any questions you have about lab 1. And then week 6, which just looking at dates, that's February 24th. We're going to be going over normal distribution, and we're going to start lab 2. Lab 2 is going to be due at the start of week 7. That week, we're going to talk about sampling and sampling distribution. And then week 8, which ends up being, let me see if I can get you an actual date here. That'll be March 10th. My calculations are correct. Yes, March 10th. That is our exam. The way it's going to go is the exam is going to go live on that date. We're going to the exam is going to be live. I'm probably going to have it go live around 4 o'clock. So you can get it started earlier. If you have any questions whatsoever as you're taking the exam, my cell phone number is on there. You can feel free to text me a question. Just let me know how I can help. But again, it should take you no longer than 90 minutes. If you need an extension for any reason, I recognize computers glitch, internet crashes, just let me know and we'll make sure to make that work. But otherwise it'll be due by midnight, really no later than the end of our course, which is 9 o'clock, I think. Our class ends at 9. I'm happy to go till midnight if you guys need it. But my goal is that you guys can complete it within our course period, the amount of time that we have. So that's what's coming up. So no quizzes until week 10. So we've got a nice little break from that. Any questions about the syllabus so far?
Good.
You're good, you said?
I thought you were asking if how we feel about the syllabus. So
You feel good about it. Okay, no, that's good. I need to know that too, but I didn't know if you had any specific questions. Hannah, you have a little friend who wants to learn about statistics. One is never too young to learn about it. Let me guess, like 15
Want to say
months?
hi? Can you wave? Can you
Hello.
wave? No? Oh, there she goes. She's trying to steal my M&Ms.
Oh,
Here you go.
smart. How old is she?
She's like 1.5.
1.5. Hello. Is this your daughter, sister, niece?
My niece.
Your niece. So
Yeah.
cute. Erin, I will admit I am a bit disappointed we did not get a show from your roommates. I told my son about it. I was like, be ready. There's going to be a show.
They were putting on a show in the middle of the quiz. They had the lights flashing on.
Oh
They
my
were
God.
drawing stuff all over the whiteboard down here. It's
Oh my
crazy.
goodness. Doesn't
Yeah.
sound like an ideal situation for you there in terms of learning. Sorry about that.
It's cool. I mean, I came down to the basement to try to get away from them. And then that's when I realized I needed paper. So I texted them. Then they made like this whole like extravagant adventure trying to get down here to me, bringing me a whole bunch of colors and all that. And they're like, oh my goodness, we survived so much hardships.
I love that this is your life because there are moments where I'm like, I need more of that kind of crazy nonsense and less of a come sit down for dinner. I turn into evil mom, like, why are you standing? I made a delicious dinner. Sit down and eat. Yeah, maybe Hannah, your sister or brother, will know about the woes of dinner time. And then was it Annette? I felt like there was a little one on your video the other day, Annette. So maybe you know about it too. Okay. I don't know if you guys can hear my dog hooting and hollering. I'm just gonna call out to him so he stops barking at the neighbor. Come inside. Oakley, come. Yes, treat. Okay, don't judge my fake out. He's not gonna get a treat, but it does get him to come. Okay, that's a good boy. You go settle. There's so many deer. Oh, was he? Sorry, Annette. Yep, my dog was going crazy. I think there's deer down in the ravines, which he's kind of scared of. And then the neighbor dogs get going. It's a whole thing. It's just a whole thing. Okay, So today we're going to be talking about measures of central tendency. So here is our PowerPoint. Let me click on this here and swap this. Okay, can everybody see it? All right. Some of this is going to be review, honestly. You guys are going to go, why are we talking about an average? I know what that is. Just, we got to stick with it. We got to start from the beginning. Before I get started, I had finished the last week's lecture, right? We were all done with that. Okay, I had a momentary panic moment. I was like, maybe I didn't. All right, so what are our goals? When we're talking about measures of tendencies, we are going to discuss the importance as to why we measure that. We're going to discuss how to calculate and interpret mode, median, and mean. Hopefully those words are somewhat familiar to you, especially mean. We're going to identify the relative strengths and weaknesses of each of those measures of central tendencies. And then we're going to determine and explain the shape of the distribution that they come from. So really, we're just laying their foundation so that we can then talk about z-scores, t-tests, things like that, that again measure the central tendency, meaning where are most of our numbers, most of our participants, where are they clumped around, which is around the center. That's why it's called a measure of central tendency. Okay, so overall, measures of central tendencies all have the same thing in common. They describe what is average or typical of a distribution. So you'll often hear the mean age of CEOs is la 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 la, or the median income in this neighborhood is X amount of dollars. Why is it important to talk about these measures of what's in the middle or what's typical of the distribution? Why do we do that?
To give like a rough estimate of, I mean, it depends on what you're talking about, but for like the CEOs to see like where people should hope to be at, or just to give like society a general like idea of certain like measurements. That makes sense.
That totally makes sense. So what I'm hearing in your description there, Camilla, is you're talking about measures of central tendencies are helpful because they allow us to provide a comparison, either for yourself, like what you should aspire to, or what it means in relation to others.
Yeah.
Okay. That's really, honestly, that's the main thing. So we care about where the average or the typical individual lies, because then we can make an important and valuable comparison when we introduce either a single score or ourselves or a goal, right? So if we say, I want to be able to bench press, oh gosh, I'm already out of my reach. What's a big bench press that's like this, right? Was that 150? Is that little? Someone needs to give me some perspective here. 100? 400? Like what's?
Well, the bar itself is 40.
Okay.
I think usually whenever I hear people talking about it, they're always talking like somewhere in the 200s.
Oh my gosh, that's a lot. Okay. So let's say I'm like, I'm going to get fit this year, and my goal is to bench press 40 pounds. Okay. Let's say I'm that person. I'm just going to start nice and easy, 40 pounds. I might go like, I'm kind of amazing. I can bench press 40 pounds, but unless I have some sort of measure of comparison as to what is the average person bench pressing, that's not going to be meaningful. If then I find out that most people bench press 125 pounds, I'm going to go, oh, I need to up my game. Similarly, somebody who's been doing this their entire lives, they're super buff, like fitness is their life, and up against their peers, they're bench pressing kind of a low amount, and they're like, yeah, I'm only at 300. I'm not doing all that great. Measured against the entire sample, which would be like the average American who works out, this individual is quite likely way above average, right? Even though their immediate peer group may be higher, okay? So we look at, did you have a question?
Oh, sorry. Liliana keeps hitting my computer.
Oh, no, that's okay. I want to make sure you didn't have a question. All right. So a measure of central tendency really describes what is typical for a given individual. So it gives you a ballpark. Parents love measures of central tendencies, right? They want to know, hey, little Liliana maybe is, I don't know, I'm going to guess here, 28 inches tall. Is she considered tall? Is she the next, center for the WNBA team, wherever they may be? Or is she kind of petite? And then we need to look at her being on a rowing team, right? Like, so parents love that. They want to know what is the norm so that they can then compare their child's value to the norm. The idea of a specific measure of central tendency is that it is really the middle of a distribution, right? So if I were to draw, let's see here. If I draw something like this, right? Where is my middle? Where is essentially my most common score? No trick question here. What does it look like? There's
In the
no
middle.
number, obviously. What's that?
Probably right of the curve.
Curve.
Yeah, so like somewhere like right here. Right? Okay. That is the most common score, which means if on this axis, because this is what it is, right? You've got whatever the score is, right? Whatever that might be, if it's height, weight, how much you can bench press, intelligence, anything will be on the x-axis. And this here is a frequency. Okay, he is just gonna drive me crazy tonight. All the way up. Good boy. So, whoops. So this top value right here, where is my cursor? This top value right here is the highest level of frequency. So that is the most common score. And for a normal distribution, it falls right at the height or the apex of a normal curve, okay? So this is especially helpful when we're analyzing multiple variables, when we're trying to figure out what is it we're looking at, what's a common score. And then oftentimes that's the way in which the numbers are going to be communicated. So in some disciplines, frequency distributions are rarely reported in research articles. So you're not going to get a frequency table. You'll just get a mean score, right? Which will tell you like most people performed at this level. Okay. So let's talk first about the mode. The mode is the category or score with the largest frequency in the distribution. Oh man, Hannah, you're having all the visitors tonight. It can be calculated for nominal, ordinal, or interval ratio items or variables. And this is a common measure of central tendency specifically for nominal variables. Here's the reason why. With a mode, I'm counting how often was a particular value given. So I'm not doing an average, which that would be a mean. I'm not doing any sort of calculations with a number. Instead, I'm looking how often this occur. So for instance, I could ask, which religion has the most number of people? So I'd go around, I could pick a random sample, ask people, hey, what religion do you follow? And then I would keep a frequency and kind of tally, Christian, Catholic, maybe I'd have, Jewish, Islam, Muslim, just whatever it fell into. And then I would see which of those categories had the most numbers. And that is the particular variable that would be the mode, right? That number would be the mode. The mode is very rarely used for numerical or quantitative variables. It is most often used with nominal variables. So again, when you're thinking about specific categories. So let's look at what that might look like. So maybe I'm looking at the religion, again, within the US, I have a sample size, let's say 600, 6,000, whatever, some high number. And then I can see how it's broken down. So 73.7% stated they were Christian. And then you can see the breakdown here between Protestant, Catholic, and Mormon. 18.2% say they were atheist, agnostic, or had no faith. Then there are 5.4% were non-Christian faiths, which is Jewish, Muslim, and other non-Christian religion. And then 2.6% ends up being a no response given. Okay. So in this case, the mode, the most frequently occurring value would be Christian, right? That'd be the most often noted. Now, there's no way that we could quantify this, right? Like we couldn't say, oh, the mean is 7.2 because Christian is 10 and Judaism is 3, right? Like there's no numbers associated with this. So that's why a mode makes sense, because it's nominal data. Okay. You can, though, use the mode even if you have numerical values. So the mode is the high point in the distribution's histogram. And this is an example for the number of dreams during a week for 10 students. Okay. So I would be asking 10 students, how many dreams did you have over the course of the last week? Okay. And based on just who I can see right here, maybe Liz would say, I had 1 dream. Maybe Aaron and Hannah said, oh, we each had 3 dreams. Maybe Annette and Diana and Stephanie said, I had 8 dreams. Camilla had 9. Mallory and Lainey had 7, and Hasher had 6. Okay. So based on that, I would write how many times each person reported they had that many number of dreams. The most frequently occurring number here is 8. So the mode would be 8. Okay, I want to make sure we're all together on this. Does this make sense? Okay, this is the time to ask if you're like, what? How is that making sense? Okay. All right, so let's practice it together. You guys take a look at this chart and you tell me what is the mode. So take a moment, look it over. What is the mode?
8 dreams in a week.
I can't hear. What was that?
8 dreams in a week.
No, for this slide right here. Are you able to?
Oh, sorry, my computer's really lagging. I can
Oh.
still.
No, it's
still
okay.
do the last one. I'm sorry.
Aquinas. Is it
Do you
Aquinas?
see it though now, Diana?
I see the names of the colleges. Yeah.
Okay.
Sorry.
No, it's okay. Take a minute. I'm gonna tell my husband to get the dog because he is barking like crazy. Annette, I'm sorry if your dog's going crazy too. Okay, so based on this, what is the mode?
Aquinas.
Aquinas. And how did you figure that out?
I just counted it and it came up the most.
Okay, so if again, the mode is the most frequently occurring number, and Aquinas is the most frequently listed as where they go to school, that would be the mode. Any questions about that, or did everybody get that? We're good? Okay. So now if I were to look at this again, same idea. What is the most common, most occurring foreign language spoken in the US? Okay, you guys might have an idea in your mind as to what it is, but let's look at this data. So this is a chart that shows us the 10 most common foreign language spoken in the United States between 2009 and 2013. And you can see all of these languages are actually in ascending order, maybe you'd say descending order actually, for the most frequently spoken or the greatest number of speakers all the way down to the least number of speakers. Based on that, the greatest number falls in the language of Spanish. So Spanish would be your mode. Okay. Still tracking? Still make sense? Okay. Let's switch gears a little bit. Now let's talk about the median. The median is the score that divides a distribution into 2 equal parts so that half the cases are above it and half the cases are below it. So Whereas the mode is looking, what is the most frequently occurring number? If I have a clump, and let me draw this out right here, because this is where it really gets tricky. Okay. So let's say I have this chart, right? I could have a clump here and then a clump here. Okay. I think we talked about this last time. This is called a bimodal distribution. Bimodal because there are two modes. There are two areas that are the highest number, right? Okay. The problem with that is that I could say it's this number, but that is taking away this entire section here, this entire population that's really not being accounted for if I give this as the mode. The median instead says, let's count how many numbers there are all the way across. I'm going to just put them all in ascending order and right smack in the middle. What is my middle value? That is what's going to be the median. Okay. So it is the middle score or the average of middle scores in a distribution. The reason why it says it this way is if you have even numbers, then you need to take the average of the two middle numbers. If you have odd numbers, then you can just get the middle score. So for instance, the median weekly salary of full-time US workers in 2015 was $825. That means half of the workers made less, half of the workers made more, okay? Can you guys think of a reason why a median would be better than, let's say, an average?
If there are outliers, you don't want it to skew what you're saying is average or for the central tendency.
You're spot on, Diana. That's exactly right. If you have any outliers, that's going to like really artificially increase your average. Because again, if I'm taking a poll out of all of you guys, I'm saying, how much money do you make? And one of you happens to be a brilliant, I don't know, stockbroker, and you're making all this money. You're like, I doubled down on GameStop when it was the best time to do that. I hope everybody's reading the news. Anyway, and you made a ton of money, then you've got a student who's a millionaire, right? That number is going to really push our average up. It's going to drag it up. So outliers heavily influence the mean or the average. It does not influence the median as much because the median just orders all of the scores and says, which one is in the middle? That's the one I want. Okay, right smack in the middle. So especially with salary, most often, or like prices of homes, they'll say median rather than mean because that is impacted by outliers far more. Okay, so again, the median is the value at which half of the ordered scores fall above and half of the ordered scores fall below. So if I have these 5 scores, right, I order them from lowest to highest, and I select the middle score. So in this distribution, the median would be 3. In this distribution, note it's an even number, so I don't have a middle point. So I have to take the 2 middle numbers, add them, and divide it by 2. So 2 plus 3 equals 5. 5 divided by 2 is 2.5. So my median for this distribution would be 2.5. Okay. Pretty simple. Got it? Okay, so this is going to be a formula you need to remember. Oftentimes we will have median, a specific distribution that has odd numbers, so it's very easy to identify the middle number. But when there's an even number in our distribution, we need to remember to find the 2 middle numbers and average them. Okay. So this is the number of hate crimes reported in the 9 most populous US states in 2014. Okay, so we're here. Let's see it. So that is the number of hate crimes that are reported. Again, the 9 most populous states. So Michigan is one of the most populous states. So take a moment, arrange the numbers of hate crimes in order from lowest to highest. So take a moment and do that. I realize, of course, the answer is written there, but just try to do the exercise too. Okay, did everybody get to it? Okay, so we have 9 states. You can start ordering them from the lowest one to the highest one. What was the lowest state for the number of hate crimes?
Pennsylvania.
Pennsylvania, right? Okay, so then you went Pennsylvania at 50. Next up was Florida at 65, right? And then you probably went over to Illinois at 109. Then North Carolina, right? You just kept going up and up and up. What was the most hate crime? Which state had the most hate crimes?
California.
California, right? At 759. So now I have them all organized in order. And by eyeballing it, I can pick the middle one, or I can figure out what is my midpoint. The way to do the midpoint is to do 9, whatever your n is, plus 1 divided by 2. So you figure out exactly your midpoint. Again, some of you guys are going to be more visual. I've seen students do this often. Let's see here. Okay, so if you have, 7 scores, they're going to go, okay, so the highest to lowest, I'm going to erase that, then second, erase that, here, and now I know that this one is going to be my middle number, right? They just kind of knock one off on either side until they get to the midpoint. But I want you guys to recognize this is for an n or distribution of 7 numbers. If I were to do 7 plus 1 divided by 2, my response would be 4, right? So then I would be able to just count to 4 and do it this way rather than checking things off. It's just to show you the formula actually works. So knowing that, then I would know that the 5th case, or the 5th state in this case, is going to be the one that's right in the middle, which would be Texas at 145. Okay, which means there's exactly half of the states, half of the cases that are above it, and half that are below. And again, that's the goal of a median. It's to split the distribution in half so that I know exactly where it lies. So I'm right in the midpoint. Okay. Is that making sense? Okay. All right, let's move our faces here. The number of hate crimes that are reported in the 8 most populous states in 2014, again, we're doing the same kind of deal here. This one, we're just doing 8 states rather than 9. So we're eliminating the lowest state, because remember here, we had a Pennsylvania was 50. So we just did the top 8. So that kicked off Pennsylvania. So I would organize them again in order. But now if I do 8 plus 1 divided by 2, that gives me 4.5. That's not great, right? I don't know which of the states is 4.5. So that tells me I need to go right in between. I need to get an average of these 2 positions right here between 311 and 145 divided by 2, which would be 228. So that would give me the median number of hate crimes in the 8 most populous states. It would be 228. So again, because there's not an actual number clearly that I can pick, I have to take the average of number 4 and 5. Make sense? Okay. All right. You can also do this with a frequency distribution. So this is a respondent's political view according to the Global Social Studies Survey from 2014. You can see their political views are labeled extremely liberal all the way down to extremely conservative. You can see the frequency for each. There's then a cumulative frequency, which we talked about last week, the percentage and cumulative percentage, okay? So if I look at my total N, the total number of respondents in this particular study, it was 1,442. I add that plus 1 divided by 2, which gives me the 721.5th case, right? Well, that is hard to know exactly where that is, but if I were to plot it in, it would be somewhere right in here, okay? It'd be between that 400 and 965. So the median would be right around the moderate range. This is one I'm not going to be asking you guys in an exam to do that, like specifically with a frequency distribution. I think that gets a lot more tricky. I think finding an actual midpoint and median point in a distribution makes a lot more sense. Okay, let's talk about percentiles. When you guys hear that, like 5th percentiles, 20th percentile, what comes to mind? What's your go-to with that word?
A baby.
A baby? Tell me more about that, Liz. Or is it Liz?
It's Lainey.
Oh, Lainey, sorry. I can't see your face.
Oh. Well, my camera's on.
There you are. Yes, I was on the second page. Okay. So what do you mean about baby?
I just, when like babies go to the doctor and they're measuring their height or their weight, they're like, oh, they're in the 75th percentile or something like that.
Yep, exactly. And so what are they doing when they say that, when they're using the word percentile?
Like the majority, they're in the majority of 75% of the people.
Okay, you're on the right track there. Anybody else have another thought on that?
Isn't it like 75% of like babies born are with like that same height maybe?
Okay, yep, you're heading right there. So the idea of a percentile is that it's a score that falls within a specific percentage of the distribution. So if I were, and again, the best way to think about this, and with babies, you're absolutely right, Lainey. You hear about that all the time. Your baby was 8.5 pounds and fell in the 85th percentile for weight. What does that tell me? That's telling me that out of 100 babies, if they line them all up, one next to the other in terms of their weight, your baby would be the 85th heaviest out of 100. Okay, let's flip it upside down. That would mean 15 babies would be heavier than your baby, and 84 babies would be smaller or lighter than your baby. Okay. So the reason why we utilize percentiles is it makes it easy to think about 100, right? And it puts them in order. So wherever you fall on a percentile, whatever that number is, you can look to what is above. That's what's above you, greater, heavier, taller, smarter, whatever it is, the measure it is, that's what's above. And then whatever is below, obviously is below, right? So it means that you can also think about it in terms of quartiles. So that's what I talk about there, the upper quartile. If you were to take 100 and you divide it by 4, right? That's 4 pieces of 25. If you're in the 75th percentile, you're in the upper quartile. Okay, that's another way to think about it. So again, if you're at the 50th percentile, you're right in the middle. That means 50 or better, 50 or less, right? Or so, 49, 49, right in the average, okay? Percentiles can be very helpful because they're easy to understand for most folks. That's why they're used by the pediatrician. And what other context do we hear about percentile that you guys can think of?
For scores on exams like the SAT.
Absolutely. Standardized testing definitely uses percentiles. Anything else comes to mind?
Incomes?
Income. Okay, so if we were to line up incomes, you would know I'm in the 90th percentile of income for this region. Sure. Anything else? Okay, we've come up with a lot of good examples. So again, if you were to line them all up and come up with 100 people, it places you with those average 100 people, and it tells you where you would fall. Again, the reason why percentiles are helpful is it provides an easy comparison for people to understand, right? If somebody told you, and I feel embarrassed to say this, did most of you take the SAT or ACT? Those are totally different scoring, right? I only know the SATs. SATs? Okay. Back when I took it, it was 2 sections that were out of 800. Is that how they do it now? Or there's multiple? What's a good score on an SAT?
Like anything over 1200.
Okay. Thank you. So if somebody said to your grandma, Grandma, I scored 1400 on the SATs, she might go, oh, well, that's good, dear. I don't know what that means. What's 1400? I don't know the range of scores for the SATs. Even I don't know it because I feel like it switched back and forth there for a little while. So I don't know whether 1400 is really good, really bad, kind of average. But if I talk about percentiles, that is a standardized way to talk about numbers. Whether we're talking about a test score, height, weight, the same thing. If I told you that my toddler was 33 inches tall, you might go, okay, what does that mean, right? Now, I could think she's incredible and the next basketball player because she's so tall, but unless I standardize that score in a certain way by giving you a percentile, it's likely to be meaningless, right? Unless you have firsthand experience with that specific thing. So again, with the SAT scores, if your grandma happens to be an SAT test proctor or an instructor of the SAT test prep, maybe then she'd be like, whoa, let's celebrate. We're getting you a bundt cake, whatever it may be. But otherwise, there might not be a good frame of reference for it. This is why percentiles are so powerful and discussed so frequently. So academic achievement usually fall in that. Oftentimes they'll talk about even sports or like athletes within given sports where they fall within their own groups. Cars often will talk about that, like in terms of crash rating, where they fall within other cars that are of similar class. So that it's a good way to standardize what you're seeing. Okay. So this is another graph that talks about percentiles. This is the days per week having dinner with parents and monitoring the future. So that's 2014. So the number of times per week that you have dinner with your parents, okay, less than 1 day, which can we pause on that? Why is that not 0? Do you have a half a day? I don't know how that goes, but anyway, so less than 1 day is 1445. Then you see 1 day, 2 days, 3 days, 4 to 5 days, 6 to 7 days per week. And then you see the percentage throughout here. Now, what would be the median here? Meaning which category is at the 50 percentile or below? What do we think?
4 to 5 days per.
What is that?
4 to 5 days per week.
And how did you come up with that, Diana?
Because 41% would be too low. And so 62% for the cumulative percentage is like the highest, like it has 50 in it, but you can't go lower than that because like lower than that in terms of days per week. Sorry, I didn't know that well, but
You're totally on the right track. I think maybe my internet's a little funky. I'm having a hard time hearing everything you're saying. It's a little laggy. But I think you're saying 4 to 5 times per week because it seemed like 3 days per week was going to be too low because the cumulative percentage, as we see here, would only be 41%. So if we're looking to get to the 50th percentile, it would have to be within this category. and you're absolutely correct. Okay, so that would be the median. So that encompasses about 50%, would be above that. They would do more than 4 to 5 days a week, and 50% do less than 4 to 5 days a week. Okay, good job. All right, and then lastly, the mean, which is something that we all know. We often don't call it the mean, we call it the average. That's the most common term. It's a measure of central tendency that is obtained by adding up all of the scores and dividing it by the number of scores present. It is called the arithmetic average because, again, you are doing a summation of all of the numbers that are present in your distribution, and you're counting the number that are present in your distribution and dividing it by that, or your sample size, or your n. This is usually used for an interval ratio variable, and it's best known and most widely used. Most often in research articles, you will see, maybe there'll be a frequency of males to females, but then you'll see a mean of age, you'll see mean maybe of height. That's the most commonly occurring measure of central tendency. Okay, but the mean is often not an actual number that can be found in the sample distribution. And that goes back to, I think, Diana, you were the one who was talking about skew and outliers. Outliers will pull the mean to go either higher or lower than it needs to be. So it's possible that you get a number for the mean that is not even present in your distribution. Okay. For instance, let's take a quick example. So if you guys could tell me, where's my cursor here? How many kids are in your family of origin? So you're one, right? Do you have siblings? How many kids are total, right? Okay. And then either shout it out or type it in the chat. Okay. So I'm seeing 3, 2, whoa, that's going fast. 4, 3, 2, 4, 2, 5, 3, 2. All right, I've got 8 responses. Anybody else? Make sure I'm not missing anyone. Okay, so I've got 10 responses. How many people are we in the class? We've got a few people who didn't respond. Oh, here's another one, Hesher. Okay, and I will tell you, for me, I'm one of 5 as well. Okay, so I'm gonna type in the chat the result of this so that it's all together. Okay, can you guys see this? There should be 12 responses. Okay, so look at that list of number, figure out the mode, the median, and the mean, just with that, for average number of kids in your family. And I'm gonna do it right alongside you guys. All right, do we all have our answer? Do we need another minute? Sounds like maybe another minute. Okay. Just let me know if we're ready to go. I don't want to pressure you guys, and looks like you're good. Okay. Good. Good. Okay. All right. Let's go over it. So, in order to find the mode, what's the first step? What did you have to do?
You had to like find out which was the most common, like kind of. I guess the way I kind of do it is almost kind of like keep a tally of which one kind of comes up the most.
Okay, so again, the mode is the most frequently occurring number. So you need to figure out which one occurred the most frequently. Sometimes it's going to be as easy as just eyeballing it. Sometimes you'll need to order them and figure out which one happened the most. Other times you'll need to create a frequency table. Okay, and what did we discover was the mode? 5. I'm seeing Aaron say 5. And a couple people in the chat say 5. That is correct. Mode was 5. Now, how do you go about finding the median? So Hasher, you're spot on for the mean. For the mean, you add them all up and you divide. That's how you get the mean. But what about for the median?
Because there are 12 numbers, didn't we have to find, yes, because there are 12 numbers, that's an even number, so you have to find the 2 in the middle and then find the number in the middle of that.
Exactly. Okay, so what are the 2 numbers? So first off, Stephanie, you're right on the right track. You find the 2 that are in the middle. The best way to find those 2 is first to take all of your numbers and put them in order from smallest to largest. Then you can go back to the middle, find those 2 values and come up with the average of those 2. Okay, good. What was the average of those 2?
3.5.
Is that what everybody got? Okay, 3.5. So we ordered all the numbers. So we had 2, 2, 2, 3, 3, 4, 4, 5, 5, 5, 5, 5. So if we're going right in the middle, let me double check that I'm doing the math correctly because I got a different number.
Wouldn't it be 4.5?
So let's see here. 6. I think it's just 4, gang. Okay, so if you order all the numbers, here's what you get. Okay, this would be in order. Does everybody see this in the chat?
Okay, that makes more sense.
Okay, so then I have 12 numbers that I've lined up in order. So like I said, you could do it, knock off the first and last, then second to last, then third to last, then fourth to last, fifth to last, and then I'm left with 4 and 4. Those are my midpoints, which means there's 5 higher and 5 below. Now 4 plus 4 divided by 2 equals 4.
Mm-hmm.
Okay, So again, this is a common error. I'm glad that you pointed this out. So you just want to make sure you order them from the beginning, right? Lowest to highest, get back to the middle two numbers, make an average of those, and that is your median. So in this case, the median is 4. All right. Now, what is the mean?
I got like 3.75.
Okay. And how did we figure that out?
Take all the numbers, add them up, and divide by how many there were, which was 12. So it's like 45 divided by 12, I believe.
Yep. So all of these numbers that I had in the chat a minute ago, so 6 plus 6 plus 8 plus 25, essentially, I'm just adding them up quickly, divided by 12, then equals 3.75. Now, this is the whole point about the mean. Was 3.75 a number found in our distribution? No one was like, yes, my family, we are 3.75 children, right? Like no one is saying that. So the mean is taking all of these numbers and just simply giving them all equal weight, dividing them by the number in the sample, which gives us to 3.75. So this is a perfect example. I'm actually really excited. Sometimes it doesn't quite work out because people are like, oh, it's all the same number. So it doesn't really add up. But in this one, we had a median of 4, a mode of 5, and a mean of 3.75. That's quite a bit of variability, right? So if I'm a researcher and I am motivated to try to skew the data in a certain way, depending on which method of central tendency I use, I will get a different result, right? Okay. Just interesting to think about. All right. So that is the mean. Let's look at a few more things then with measures of central tendency. This is, again, if we're looking at salary. Salary is probably income, salary, whatever you want to call it. That's one of the most heavily disputed things to report because they are so highly susceptible to skew, right? Because in any given sample, you are going to have people who make way more money than others. So in this distribution, you see, in fact, a bimodal distribution. So this here is fairly normally distributed is what it would be called, which means that there is a mean, which would be this number here, which I mean, or this not mean, mode, should be close to, I don't know what that would be, around, let's say 50,000. So if I were to stop the graph right here, I would have a nice distribution here. But as it goes down, you can see the tail gets smaller and smaller. I then have a secondary spike right over here, right at around, I don't know, that's like 160,000 or so. All of a sudden, that's my second mode, right? That's a most frequently occurring salary, which, you know, it's not a bad day if that's the most frequently occurring salary at 150,000. But you can see here, you have the adjusted mean and the mean. So the mean is if I were to take all of these numbers, add them all up together by the total number of instance, that would give me a mean of 82,408. The adjusted mean takes into account the fact that the bulk of the people fall closer to this group. So with multimodal distribution, you have to be mindful of that. I am not going to ask you to do an adjusted mean in this class. I'm going to ask you to calculate mean, mode, and median. But it is important for you guys to understand that, again, if you have a distribution that looks like this, depending again on what is the goal of the researcher, they could be portraying or sharing data that is grossly inaccurate, right? Grossly inaccurate. Okay. Let's look at formulas. You're like, eesh, oh, the light, I'm melting. Formulas, math, it hurts. It doesn't hurt. It'll be A-okay. You guys all know this already. You just didn't give it fancy Greek letters for it. How do we calculate the mean? The mean can be shown, your textbook specifically does a capital Y with a bar on top, okay? Most commonly known, it'll be an italicized capital M. That is the mean. But the rest of the formula is the same. It is the sum of the instances seen for variable y, right? Or the raw scores of variable y. But this is a sigma, which means you sum them, you add them all up, divided by n, which is the number of observation or cases within your sample. Okay, you guys all knew this without the fancy formulas. Add it all up, divided by the number in the group. Okay, so that's what you're doing. But know that in terms of terminology, when you're looking at research papers and they have a capital italicized M, that means mean. Okay, occasionally you will also see this. Oops, I'm trying to switch it. You will see an X with a bar on it. Okay, that means sample mean. Okay, specifically with a sample, not an entire population. This is the mean of a sample. And occasionally you'll see one of those mu, right? That is the sample for a population. So if I have an entire population, that is how I would notate the average or the mean for that population. Okay. So another example. Here is a distribution. If I want to know what is the mean, what I would first do is add them all up together, right? That's the capital sigma. And then I would, can I go back? Yes, sorry about that, Grace. What's your question? Did you have a question, Grace? Oh, the formula. Yes. This is also in your text. And remember, I'm recording every lecture, so you will get to see it again. In nights where you're like, I can't fall asleep. Whatever shall I do? Pop one of these bad boys. Perfect to go right to sleep. All right. So the mean of all these numbers in this distribution will be adding them all up, right? So you're doing your capital sigma. So see, here it is. I get a total of 60, okay? Then I need to figure out what is the size of my sample. In other words, what is my n? That's literally counting how many numbers are there in my distribution. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have an n of 10. So to figure out my mean, I take the sum score, which was 60, divided by 10, and I get a mean of 6. Okay, making sense? All right, now let me show you just graphically what that would look like. If I were to plot, these are the exact same numbers that were right here, okay? But put in a visual distribution so you see what it looks like. You see that there's one instance of 1, 2 instances of 3, 1 instance of 6, 2 of 7, 3 of 8, and 1 of 9, okay? So now you see kind of where it falls. This is with their weird example again with the number of dreams per night. I don't know, that's weird. Do you guys think that through? Like when you wake up in the morning, do you go, how many dreams did I have? Or is it more, did I dream or not? For me, it's very binary. Yes, no, not necessarily how many I had. What are your thoughts on that? I've gone on the deep end. I don't know if anybody will. Okay. Thank you, Hannah. Oh, you have multiple dreams per night. Lainey, you're like me. Okay, good. That makes me feel better. Yeah, I can't ever go like, I had so many dreams. But again, I would be one of these guys right here in the one. Same. Yeah. Okay. All right. So if I am looking at calculating the mean of a frequency distribution, this looks a little bit different. We'll look at it in just a second. So you would be doing, again, this is the mean. This is the symbol that shows your mean for your sample. You are using a sigmoid, or the sum of all of the frequency times the raw score divided by the number of observations. Okay. This looks scary. Again, numbers, formulas, don't like you, don't want you. Quite simple. Let's go to an actual example. It'll all make sense. So this is the number of children per families, very similar to what we just did. And this is the frequency of how many people said, yes, there are 0 children in my family, which is odd to say. Probably your current family, you have 0 children, or you have 1, 2, 3, 4, 5, or 6. Okay. The way you do a mean from a frequency distribution is you just multiply it. So there are 8 individuals who said they had 0 children. So you do 8 times 0 equals, shocking, 0. Okay. There are 29 people who said they had 1 child in their family. So 29 times 1 equals 29. 477 people said they had 2 kids in their family. 2 times 477 equals 954. Okay. Using tables is going to be your friend. I'm a visual learner, so definitely helps me to just have it all laid out. The reason why I think, especially for this, it's helpful is that you can write it out in this column and then you can sum it. Okay. So what I'm doing is I'm adding up all of these scores, which is the frequency times the actual response or the variable, which gives me a total of 2,173. Okay, this is the sum of the frequency times the variable. Now I divide that by n, which is my sample size, which is given right here, 862. And that gives me an average, again, of 2.52. So how many kids do you have? 2.52. It lies right between 2 and 3, right in here. Okay. That is the way you would run a frequency distribution to calculate a mean. Okay. Does that make sense, everyone? Okay. Now, this is another table. We're looking, again, populous states. So this is the incarceration rate per 100,000 people for 10 of the most populous states. So this is the incarceration rate, again, per 100,000. You get the states listed right here, and then the numbers are listed right here. If I look at what is the average incarceration rate or what is the median incarceration rate, that's going to look a little different. Specifically, if I'm interested in Michigan, which is 437 right here, okay? So the proportion of people in jail in Michigan is 0.437%, okay? Now, how did I figure that out? What do we think? You're like, you did magic, Dr. Woltzel. We don't know. The key is right in here. Okay. So if I'm looking for the proportion of people in jail, I need to take this number, 437, and divide it by 100,000. And that gives me my proportion, which is 0.437%. You guys see how I did that? Okay. What is the proportion of people in jail in the state of New York?
Point 265%, or actually times by 100, I guess.
No, you're right. So you could say 0.265% or 0.00265. Those are the same. So yeah, that works. Okay, very good. All right. All right, let's talk a little bit more about the mean. There are several things that we need to remember that are specific to means that do not necessarily apply to median and mode. First, it is an interval ratio level of measurement, which means there is a meaningful difference between numbers and there is an absolute zero. So you cannot do it on a nominal variable, right? What's the average of religiosity? Oh, you're 4.2% Protestant. We're not doing that, right? Like that's nominal values. It needs to be an actual number that has a meaningful difference between each score and has a natural zero, okay? There needs to also be a balance point, some sort of midpoint. Unlike the mode and the median, it incorporates all of the scores in the distribution. Okay, if you think about the mode, you're only looking at the group that has the most frequent number that's present, right? Or the median, you're lining them all up and picking them a number. With the mean, you're adding everything up. So there's an equal weight to every number within a distribution. Okay. If you subtract the mean from each score and add the difference, the sum will always be zero. This feels like some sort of voodoo magic, but this will be especially important when we look at standard deviation. Okay, downsides of the mean. It is extremely sensitive to extremes. Another word for extremes would be outlier. Anything that lies further in the tails away from our normal curve. By the way, we call this, whoops, where is that? So when I draw a normal curve, which gosh, this is terrible. Can you even see my normal curve? It's like red on orange. It's hard to see. This section here and this section here is called tails. Those are the tails of the distribution. That means there's way fewer people in those tails. But even these outliers that fall right in here get counted with an even weight when I calculate a mean. Okay, so it will get pulled in whatever direction where there is an outlier. Okay, this is again why income data is almost always reported as a median, because you are always going to have that anomaly or outlier that's making, you know, $8 million a year where the rest of the world is making 32,000 a year. You know what I mean? So if we were to add it all up, that outlier would really pull that mean much higher, and it would no longer be representative of our distribution because it would get pulled too far out to encompass the outlier. Okay. What happens with the mean is really the seesaw principle. I feel like what this always reminds me of is when you stand on one of those old scales at the doctor's office that has the weights and you're kind of pushing it along, then you push the little guy over and it's like you're trying to balance it. Am I really that old? Do you guys know what I'm talking about? Okay. Okay, you've all seen a scale that's not digital, right? Like where you're moving the big chunk, right? Okay. If you move it all the way to the end, you'll see it go clunk. It totally kills it, right? And then you scooch, and then it's like, oh, okay, all right, I'm right back in the middle. This is the same type of seesaw principle. If you have a random outlier that is way far out, it's going to do what's happening in this middle ground right here. It's going to really pull the mean to want to go in that direction, okay? Because see what happens here, this guy is pulling the mean to be really closer to this 140 number in order to balance it out. So you need to be very thoughtful. And later when you guys take research methods, I think most of you will be taking that, we'll talk about exactly how to manage outliers. And the issue is with an outlier, you need to really give some thought of should it be kicked out of my distribution because it is an anomaly, okay? Now imagine you are trying to figure out the average height of your high school student, like senior class year. You're like, let's measure average height. And you happen to have LeBron James on your high school team. Are you like, dude, you're messing up my numbers. Like you are not representative of the average. I need to kind of kick you out. Because what you'll do is you can see if I add him in, here's my average. If I take him out, here's my average. It's going to be a huge shift, okay? So when you're doing research, as a researcher, you will need to figure out whether outliers need to be kicked out of a distribution or whether they need to remain. And that's going to be a judgment call that you make at that point, depending on what's going on with that. Okay. Is that making sense? The implication of an outlier for the mean. Okay. Okay. So the effect on the mean and on the mode of changing some scores, this is using the example of the number of dreams during a week for 10 students, okay? So if you look here, this is this distribution right here. The mean is 8.3, and then your mode would be 8. Okay? Everything's right above it. Here's a different distribution. The mean would be 5.1, but the mode is still 8. And again, here is a mode of 8, but my mean is 7. So there is significant shift in the mean score based on the skew of the distribution. This is a distribution that is skewing towards lower numbers. This is what would almost be called a bimodal distribution, so it'll hang closer to the mode. Okay, so it's very susceptible to outliers. All right, how are we doing? How can I get your faces back? I messed things up. Here we go. All right, so we always need to also consider the shape of the distribution. As you guys are gathering data, seeing where it all lays flat. Again, I think I've said this already. I am a visual learner. So plotting it out and seeing what it looks like, there's a ton of data that you get just by looking at it, okay? So by looking at it right away, you'll get a good sense as to which measure of central tendency you should use. It will also inform us on the inferential test that you might want to conduct if you're doing a statistical analysis, okay? And then you'll need to figure out if you need to do a data transformation. It is possible in some cases that you'll want to transform your data to a z-score or some sort of other standardized score because you have such a great effect with outliers. If you have a normal distribution that is evenly distributed, meaning it is completely symmetrical, first off, stand up and do a cheer because that's very exciting. Very rarely does that happen, okay? And by that, I mean, you're getting your standard bell curve. Gosh, this is not a drawing class. We'll just say that right here. Symmetrical means if I were to cut this in half and I folded them together, it would be perfectly identical. Meaning from my central tendency point or my mean, I have equal representation on either side. Okay, that's what's called a normal distribution. Oftentimes it's called a bell curve. That's again, if you think about an exam being perfectly made, you would have your average or your mean be right around a C, maybe C plus. So if this again was your like C plus, then you have, your folks who are, my favorite students, all of you, A plus right here. And those were like, oh my gosh, am I in this class? I didn't even know I was enrolled, right? F, okay? So on a specific test scores, this is what every professor is striving for, because this means the test was a discriminating test in a good way. That's the only way discrimination is a good thing. It was the items on an exam were able to separate out those who knew the information from those who did not, okay? When you have a test that's super easy, you're like, oh my gosh, this professor's awesome. This class was so easy. Like I really grappled it all. And then you look at the test score and it looks like this, where this right here might be C and this is A plus. What do we notice? What does this mean? You're right in that. It means most people did well. Does that mean the test was good at identifying those who really mastered the information from those who didn't? Possibly. I mean, if the professor was so amazing, but it likely means, Annette, you're spot on, that it wasn't a challenging class, okay? Then you'll have this other professor who's like, I do not believe in A's. A's are only meant for the gods of academics. I shall never give it to them, right? And here's like, this would be your C and D, and like way over here is A, and there's like his favorite students who brings them Starbucks every day. He gets an A. Everybody else is in the D land, right? What's problematic with this? What do we think? Too challenging. Okay, you're right on. Could be too hard. Absolutely. Or it could also be that the test is asking questions that is completely irrelevant to the class and no one has a shot at it because they have no clue what's going on, right? Okay, so this is also not ideal. Both of these graphs, which are very poorly drawn, because again, oh, sorry, I just discovered if I use my scrolly thing, it goes up and down a slide. It's a very exciting day. Both of these are examples of what's called skew, okay? So when you talk about a distribution that is skewed, that means your distribution, the mean, is going to be a different number than your mode and median, okay? So in a negatively skewed distribution, your mean would fall right here, right around there, but your median and mode would be higher. In a positively skewed distribution, your mean would be somewhere here, right? It would be greater than the median and mode. Both of those are problematic. If you have a skew in your distribution, you need to ask yourself why that is. I'll give you an example. If you're trying to measure rates of depression amongst college students during COVID, and your depression score, you get a score from 0 to 50, let's say, and it mimics something like this. I might, as a researcher, report that the mean of depression is, I don't know, whatever this is, 60%, 40%, some number, right? That's right here representing the mean. But if this is my distribution, really, most people are not depressed or have low levels of depression. But because I did an arithmetic mean, that number is going to be pulled out further. So does it actually represent the data accurately? I would say no. It's manipulating some of the numbers. It's, in other words, finding a calculation that supports my hypothesis rather than letting the data speak for itself. Because in a distribution that is negatively or positively skewed, I need to disclose that. I need to let my readers know that most people reported they weren't depressed at all, right? It fell right in that range, that it was positively skewed, okay? But if I choose to just report the arithmetic mean, that is not telling the whole story of this distribution. Okay, so that's what this skew means. It's based on a normal distribution and bell curve, just when it gets adjusted one way or the other. Okay. Now, different types of distribution, I've already spoken to this a little bit. You can have a unimodal distribution, which means there's only one distinct mode. You can have a bimodal distribution with 2 or more modes. Uh-oh. Can you guys still see me?
Yeah, you're still there.
Yeah.
That is bizarre because I have no screen now in front of me. It just totally died. That's very curious. Okay. And you can still see my cursor?
Yep.
Okay, we're just gonna roll with it, it's fine. Or you can have a multimodal distribution, which is when there's more than one distinct mode. Let's talk about what that looks like. So this is your typical normal curve. This is a symmetrical distribution. The mean, median, and mode all align around the central point, okay? This would be negatively skewed. This would be positively skewed. I just finished talking about that as well. Now let me see. I want to go back. I'm going to go back to this real quick. So, okay, unimodal, one mode. It would look something like this, right? Okay, that is that. Bimodal would be this. We looked at it earlier, be something like this. One example of a distribution that might be exactly like that is the frequency of visiting a doctor by age. So this would be age down here, and this is frequency of seeing the doctor. So when you are very young, you actually see the doctor a whole lot, right? Because babies go to the doctors all the time. Then you get older, you see the doctor less and less and less. And then you get much older, and in your older age, you see the doctor a lot more. Okay, does this make sense? Bimodal distribution. So there's 2 peaks. Can you guys think of other examples where you might have 2 peaks like that? I can't tell if you guys are saying anything because my screen that has my Zoom is totally not there. And now I can't tell if you're talking at all.
Maybe if there's like some sort of like favorite, like I'm trying to think of a like good analogy. Like maybe if you took like some sort of survey between like 3 foods or something out of what was people's favorites, like hot dog, hamburger, or chicken wings. And most people kind of all like the chicken wings and the hot dogs, but not a lot of people really like the hamburger. It might like
Okay.
kinda, oh wait, I'm thinking of a bar graph.
But you get the idea. The idea that there could be 2 spikes in your distribution, right? 2 peaks. That's the biggest piece. So again, now that we know what a mode is, the title alone should give you a good hint as to what the distribution should look like. Unimodal only has 1 mode. Bimodal has 2. Multimodal, honestly, you guys, I'm not sure you'll ever encounter that, so I wouldn't stress as much about that. Okay, but that's what all of these look like. Oh, see? Somebody got kicked out, and I don't think I can let them back in because my screen's not working. This is the most bizarre thing ever. I don't know how. Okay, we're just gonna power through. We only have like 6 slides left. Okay, so how do we identify the distribution shape? So in unimodal distribution, it's easy to find because the mode, the median, and the mean all coincide at one point. So it's just one hump, right? That's right there. The distribution is then symmetrical. But when the mean is higher than the median, we have a positive skew. Okay, I just showed you guys that as well. Income is a typical one for that. And when the mean is lower than the median, we have a negative skew. There's an example in your book about the number of fingers. Go look at it. It's weird. Your book has a lot of really weird examples. But negative skew would be something where the mean is lower than the median and the mode. So that would be somebody who has a much higher, there's a skew on the lower end of your distribution. Okay. So when you choose the measure of central tendency, you have to think about what is it that's being measured? Are you looking at a nominal variable, like what's everybody's favorite sports team? Then the mode makes a lot more sense. Is it ordinal data, meaning how many people came in first, second, and third place, or maybe there's a percentile? Then a mode or median might make the most sense. If you're using an interval ratio item, again, that means there's a meaningful difference between numbers and there is a natural 0, then you are restricted to use the mean. That's really the only thing that can really truly capture it. Which one is best? I get this question all the time. Well, which one should I do, Dr. Wolta? Well, in your research, if you're performing research, you have to see what best tells the story of your data. That's really what you're asking yourself. What is most adequately sharing what's going on in your specific study? If you're having only nominal data, it's going to have to be a mode. There's no way around it. We cannot calculate a mean for nominal data. But if there's interval ratio items and there's a lot of skew, you should consider a median because it's going to give a more accurate number than a mean that's going to be impacted by outliers. Okay. I kind of talked about all of this already. Okay. So this is a nice handy dandy chart that will tell you what you should do. This is directly from your textbook. So if you have nominal level of measurement, you go straight down to a mode. If it's ordinal, it depends what is your research objective. You can either have the mode or median. Lastly, if you're doing interval ratio, in most cases, you're going to be looking at either mode or median, depending on what it is, but obviously the mean steps in here as well, where you average all scores. So that's really if you don't have a whole lot of skew, you're going to be able to do that. Okay. Oh, this was a super weird example. You guys, I hate that I cannot see you at all. It is bizarre to me. And now I just made it worse. Ah! Can you guys still hear me?
Yes.
Yep.
I don't know what to do. I don't know why I have one screen that's not working at all. That's kind of curious, right? Okay, discard. Hold on. I don't know what to do about that at all. Like, I'm not even sure how I'll be able to end the class because I can't see anything in front of me. And I even have a touch screen. Okay, we're gonna power through. And once I get to that point, uh-oh, I think it's starting again. That's not good. Okay, what are you guys seeing?
It's like a smaller version of the slide with the text under it.
What is happening? I can't even pull up our thing here. I'm clicking on them, but I can't see them. That is so bizarre. Okay, anybody really good with computers?
Your camera just went off now too.
No. Everything is breaking. This is what happens when you teach for like 8 hours in the course of one day. Can you guys hear me still? Oh, it's back. It's back. Okay. This is so random. Why did it do that? I don't know. Okay, we're not going to worry about it. Okay, so you guys can see this. Okay, right? Sorry, I'm going to click through to where we were. You guys are seeing, maybe getting a seizure from all my clicking. You're seeing this? Responses of 106 men? Huzzah.
Yep.
Okay. All right. So just go with it. These are not my examples. These are not my ideas of things I would research. This is your textbooks. If you're offended or annoyed, don't be offended with me. It's the textbook. This is the response of 106 men and 160 women to the question, how many partners would you ideally desire in the next 30 years? Again, why they felt the need to include this kind of question. Oh, and you still can't see my face, huh? I don't know if I can fix that. Start video. Yes. Why is this something they're like, let's talk to college students about? Okay. What do we see from this data?
Seems like men tend to have like the larger quality, tend to have more of a higher mean in the number of partners they may want over the number of years, while women seem to kind of more, I guess the best way I can kind of put it is like kind of hunker down. They don't really want to go out of their way and have like a lot, it kind of looks like.
I love the way you just phrased that, Aaron. That was perfect. Women want to hunker down. They are not desiring of spreading oats or whatever that saying is. They're not into that. They're like, let's just get it done. Okay. What else do you notice about the numbers? Because you're absolutely correct. The mean between women and men, huge disparity, right? Men are like, next 30 years, 64. I need to have, 2 to 3 partners per year at least. There's going to be some off years. So, 64. Women are like, I just want to get married. Let's have this be done, whatever, right? What do we notice about the other calculations?
They're the same for both.
They are the same. So if I am a researcher who's like, which article or which journal or magazine am I trying to publish in? And it's something like Cosmo or GQ, I might go and report the mean because that's a lot sexier than men and women want the same number of partners for the next 30 years. That's not very exciting to report, right? Okay, so I bring this to your attention because researchers do manipulate data, right? That just, it happens. We have to know this. And it's not even that they're falsifying or providing incorrect data. They're just reporting something that is not necessarily the most representative of the data in front of them. So here's a histogram that shows, or a bar graph, I should say, that shows exactly that, okay? So you can see here, men are the white bar, women are the blue bar, and you can see the percentage who noted their ideal number of partners, okay? What do you think brought the mean for men to be higher? Looking at this, what brought the number to be higher?
They were consistently had more, like
Okay.
like all the way through, whereas women were less consistent.
Okay. So it seems like, as although here women in blue are saying 8, men are saying little, but once you get up high, and Annette in the chat noted men wanted 100 and above.
There's even an outlier for 1,000 and above. Oh goodness.
I mean, I'm just concerned about the amount of sleep this poor guy is going to be getting. It's very little, right? It's just a large, that's a very high number. Okay, so we have outliers right here. I would dare say even up here that are pulling our mean to be higher for men. But we can clearly see that the median and mode fall right at the 1 value. It's the most frequently occurring number. And if you line them all up in order for a median, you would land right back at 1, okay? But again, depending on what it is I'm trying to communicate, where I'm selling this data to, I might report the mean instead. And honestly, most people feel most comfortable with a mean. They understand what it means to have an average. They've been in class, they've received an average score. But a median and mode, a lot of people don't know what that is. So again, this is part of it again. This is the data, and what are you actually representing it as? Are you being accurate with it? Okay, quick summary. The mean is the sum of all the scores divided by the number of scores present in the distribution. The mode is the value that occurs the most frequently in a distribution, and the median is exactly the middle score when all the scores in a distribution are lined up from lowest to highest. Okay. All right, you guys can review this on your own. Here's some key terms to keep in mind. And now let's do this. Stop that. Okay, are we all still here? We're surviving. Can you guys all remind me, does this class end at 9:40 or 9 o'clock?
9.
I think I am going to make an executive decision to hold off on the lab because I'm going to need at least 30 minutes to show you guys how to do it. And I feel like our brains might be at the point of capacity. So I will send a message right now in our Course Connect page. The lab will not be due next week. It was going to be due on the 17th. I'll have it due on the 24th. Semester of grace, we're all adapting, working through together. It's a-okay. I just think we need a little bit more time. So I will plan on starting class next week, going over how to do the lab, and then we'll go from there. How does that sound to everyone? I don't feel like I ever get pushback when I'm like, let's push back an assignment. People are like, no, I wanted to do it right now. Let's do another 40 minutes, right? That's the beauty of this. Okay, hope you guys have a wonderful night. Stay warm, be safe out there, and I will see you all next week. Talk to you soon.
Thank you, Professor. Have a great
Of
week.
course. Same to you.